Perfect. So thank you everyone for joining me for another one of the Siemens webinars. Today I think you're going to find this is very exciting. We're all very anxious to get this webinar out. We will be talking about the new Mastercam certified Siemens post. To give you guys a little bit of a backstory, basically we've been working with corporate Mastercam to try to get an embedded certified post in their system. So it's been a long project we've been working on for quite some time just to get through all the logistics of dealing with two very large companies. But we're happy to say that we made it, we're here, and we're going to get a chance to show you guys the fruits of our labor, so to speak. So guys, to give you for those of us that maybe haven't been on one of my webinars before, and give you guys a little bit of background, my name is Chris Pollock. I'm a dealer support specialist for Siemens on the East Coast. So basically my job is to work with any machine tool OEMs, importers, dealers that are bringing in or building product with the Siemens control, and I'm here as a resource. I do a lot of pre and post sales support. So applications training, service training, demos, product demos, that kind of stuff. So I'm always here as a resource for anyone. Probably the best way to get a hold of me is shoot me an email, but certainly if you guys are in a bind and you need to, you can always give me a ring as well. My contact information is right there in front of you. So coming up in the not so distant future, we do have a couple more webinars. I try to do these roughly every 6 weeks or so. So in the next webinar, which is going to be in December, we're going to start to look at some of our standard CAN cycles. Well, you will get to see some of this stuff today from the G-code perspective, but we're going to really delve into all of the little idiosyncrasies of some of our CAN cycles specific to milling in G-code. After that, in January, we are going to do a webinar introducing our new software version 4.7. It has been out in the field, I would say maybe about 6 months or so, but it's starting to gain some traction. We're starting to see some OEMs bringing in 4.7. So we want to do a webinar specific to what changes, what new features we've added into the control for version 4.7 that you guys can start to see and take advantage of. And then after that, in March, we're going to be doing a webinar based on macro style or variable-based programming. We like to call that flexible NC programming. But you'll get a chance to see how we can start to create unique variables, apply them, do some mathematical calculations. So it should be a real good webinar. So look forward to that. Now, two websites, or one main website and a subset of it that I would like to point out is our main CNC for You that we host here in the US. So the website is there at the top of the screen for you. There's all kinds of information that you guys can find Siemens related on our CNC for You website. Additionally, this is also where all of these webinars will get posted, so you can always go back. You can refer colleagues or yourself if you'd like to go back and view this one or any of the ones in the future. They're going to be based in this section. So we have a new look to our website for those of you that maybe haven't had a chance to go on it recently. So this is the new layout. When you click on the webinar, or the main landing page you see on the left, and when you click on the webinar tab, you select Learn More, and then you get to kind of drive in to the content you're looking for. We tried to move things around, do a little housekeeping. We found before it was all just in one giant list. So from there, you could lose track of kind of what you're looking for. So things have been cleaned up, and I think it's really a nice, fresh new look in the website. So check it out. Additionally, we do offer machine tool training. This would be instructor-led training. It's based out at our facility out in Chicago, actually in Elk Grove Village. It's just right next to the airport, not far from it at all. And that training is completely open to anybody that would like to come in and attend it. We do operation and programming training as well as service training. From the operation and programming, we have 3 different levels of classes, starting at our simple conversational shop floor programming. Level 2 would be more G-code based programming, getting into some more advanced technology, 4-axis milling, lathes with live tooling. And then I even personally host a 5-axis class there. So if you guys would be interested in coming out and attending, the training is free of charge. You guys, if you're going to take the expense of coming out and visiting us, we'll certainly would love to get to spend a few days with you. The classes are 3-day classes. So if you go to that main CNC for you and you drill into the CNC training section, you can start to see some of the stuff that we have available for you. And please feel free to take advantage of it or let your users and customers know. We're pretty excited. We got some brand new machines at our facility. So we have a new Romy lathe, flatbed 2-axis engine lathes that we can use in some of our lower level classes. As well, EMCO was gracious enough to lend us a 3-axis mill we'll have for probably the next couple years. And we got a nice brand new DMG Mori DMU50 5-axis mill. And it's a full 5-axis, so that's going to be great for me to be able to use in my 5-axis class. So anybody that gets a chance to come out, we got some new toys we can play with. Okay, so first things first, let's get into what we're here to talk about today, and that is our new Mastercam post. So this post has been designed specifically to support both the 828 and the 840, and we've gone through some very, very specific steps to make sure that this would be a universal post. We didn't have to try to maintain multiple posts and just create a whole level of confusion, which post do I need? So everything you see today is going to work on an 828 or an 840. Don't need to request or do anything different. We've specifically designed it that way. So what are we going to do? Well, we're going to talk about the post in a whole. I wanted to take a couple simple program examples that I've pre-created and then show you all the little triggers that we've embedded into the post for you to be able to quickly tailor this output to your specific needs. I mean, at the end of the day, the post processor really is probably the most critical piece of the puzzle. Yeah, it's great to have a great CAM system, it's great to have a great control, but when you're trying to use the two of them, we're very, very dependent on the post being able to translate that information, to be able to tell the control what the CAM system wants it to do. So, so here it's really important that that building block be solid. So that's what we're going to look at today. We're going to look at this post and how it works and how you can kind of tailor it to your needs. So from things like tool naming conventions, our integrated drilling cycles, how do we support simulation, and even how do we start to optimize, or how do we optimize the system for high-speed machining and some more advanced processes. So we're going to start with utilizing the post. So we're going to start with a couple simple scenarios. So these would be the two examples we're going to look at. Again, these are pre-canned little routines that I just came up to just start to give us some talking points and to show you some functionality. So we're going to do some basic peripheral or 2.5D milling, and we'll also look at some of the preform stuff when we look at high-speed cycles, cycle 832, that kind of scenario. Now the posts are supporting both X9 and their latest version 2017. So when we start to go in and show you where you can get the post, or if you're going to maybe request it from your distribution, you can ask for either versions. We're supporting back to X9 and the current version. So probably first question you might have is, how do I get the post? How do I physically get the post? So in the past, Mastercam used to just embed the posts in the install package. They still do that for the standard posts they have, but this new post, it kind of gave them an opportunity to apply a different concept that they've been playing around with. So what they're doing now is they're actually putting the posts up on a standard forum where you can go and you can download it yourself. This way, if there are any changes need to be made for server, for management control, version control, it's very, very quick and simple for them to be able to make an update, put it up on the website. They don't have to worry about waiting for a new install package to come out. So there's really two ways you can start to see this. First and foremost, if you go to the mastercam.com website and you select posts, you can drill down and get a full description of the post. And here there's some links where you can maybe request this through a reseller. But additionally, if you have a login here, so you see on the screen where we have register or login. So as long as you're a user with a licensed CNC Mastercam, you can have a login, and once the log is in place, you now have the ability to go to what they call Tech Exchange. So in that same pull down under support, a couple spots below post, there's a section called Tech Exchange. And in Tech Exchange, you can now go in, you can select the version you want, and it'll give you a list of whatever's available for the version. And there's a few different things here. They have a few tabs here where you can kind of explore some different areas of stuff that you can download. But this is where you're going to find the Siemens post specifically. So if you want to get it, simply go to your Exchange, log in, pick your version, download it, and then you're going to have the new post. So from there, one of the things you're going to see that's going to get downloaded with these multiple files is what they call this application guide. And this is a real nice document that Mastercam put together, kind of steering you through what is the post is made up of, what kind of unique features are embedded into this post, how do I apply the post. So a lot of the stuff, probably most of the stuff we're going to talk about today, is paralleled in this document. So it certainly would be well worth your time if you go through the steps of downloading the post to take a look and take a look at the post document. Is my audio still there? It should be. I had a couple people mention that it sounded like, looks like they have audio problems. If anybody else is having audio problems, yeah. Jeffrey's saying it is too. Do you guys? Oh, no. I think we're. If anybody is having audio problem, it's probably on your end. You may want to disconnect and reset up your audio connection, or just relog into the webinar. That may help. Okay, good. Sorry. So we'll keep going. Sometimes it's tough. It's a little bit of a juggling act here when I'm doing these presentations. You know, if people are having problems, I gotta keep my eye on the other screen where questions are coming in. So thanks, guys, for bearing with me. Okay, so take a look at the app guide. It's a great resource for you. Certainly, I don't expect anybody to remember everything we go through today. So you can always look at the recording of the webinar, but certainly use this app guide as a resource. It's going to be a great tool for you. So what are you going to get outside of the app guide when you download it? Well, you're basically going to get these 5 files. So with that, there's the PST file. That is your post file. It's going to be called the Siemens 3X mill.pst. There is a PSD file, and that's an encrypted file that goes along with the post. And then you have 3 other files as well. Now, it's worth noting regarding the PSB file, there was some specific content in the post that we didn't want to have people be able to potentially get into and mess up and affect the functionality of the post. So that's what the PSB is really doing here. It's not limiting the use of the post. As long as you have a legit SIM on the system, the post process is going to work. And I guess in the past, some people use the PSP file to just license the post to a specific SIM seat. For us, this is a wide open post. It's going to work for anybody that has a licensed SIM on Mastercam. Additionally, you have your machine definition file. That's got the MMD extension on it. And you have a control definition file. Now, the machine definition file, there's 2 here. One supports inch, the other supports metric. Everything else is really universal. So as we kind of go through this, the post file, the control def, that'll adapt based on whatever unit of measure you're in. So you don't, I think older posts, they used to have unit dependent posts all the time, and then you're dealing with all these different posts and version control. So they're trying to make everything as unit independent as possible. So you make a change, a simple change. Once you've tailored the post to your needs, you can bounce between different units of measure, and you're not going to have to worry about reflecting the changes you made on one post into a different post or vice versa. So these files are going to get inserted in 2 basic folders. Generally, the way it works is you're going to have a shared Mastercam folder somewhere, and the post and the PSB file, we're going to go under mill and the post folder. And additionally, the 3 other files are going to go under your shared folder and under the CNC machines. So it's just a matter of literally copying and pasting these files once you have them into those two directories. And then from there, it's going to show up. You will have to import it once you're in Mastercam, the same way you would import any different Mastercam post. And then from there, it's going to be live. So we can look at that briefly when we go over to Mastercam. So what are we going to do with this post? Well, this is going to be the basic job we're going to play around with. So we're going to take a very simple profile. We're going to do a little milling on the outside of the profile, a little bit of drilling, some tapping, and we're going to mill a hole in the center of it. So I just wanted to use this as an example to give us something that we can play around with all these different triggers that are starting to be built into this post, and you can start to see how you can tailor it. So first things first, why don't we just go through the process of grabbing the post, outputting some code. Let's get it over into our control, and let's do some initial simulation. This way you can kind of see the whole process that it would take, and then we'll start kind of cutting it apart a little bit and showing you some of these different features or functions. So what I'm going to do here is I'm going to just switch out to Mastercam real fast. And this is the pre-created part. So I have a bunch of toolpaths built here. Now, I've already built this selecting the Siemens 3-axis post. Had I not, or I was doing a new one, I can go in and I'll be able to select the post. So right now, like under mill operations, for argument's sake, you can see I have this post selected. When you first drop it in, the files in, it's not going to be in your list of whatever machines you may have selected. So you just go to Manage List, and you would find the post down here, and then it's a matter of just clicking it and adding. So like this case, I could add the metric one because I hadn't added it to my current copy of 2017. So if I plug that in there, now when you go in, you're going to get it propagated in the list. So you may have a bunch of different machine posts or control posts in here. Once it's in the library, now you can just pick it and go, and you're going to create an operation with that post. Okay, so we have some toolpath. Let's just select this toolpath, and we're going to output some code. So here, just like you would any Mastercam file, we're going to select output. We will see the post name, so you would want to validate that. And let's post it out, and we can start to see what we're dealing with initially. Okay, so I'm just going to let it overwrite what I was playing around with before. And we are going to get our first output. Things always run a little bit slower when I'm logged in with all this stuff. There we go. Okay, so here we're going to see the first example of the post processor. So we got a few unique things going on here. We have our initial tool library, it's a list of all our tools. You start to see some different CAN cycles that you might not be familiar with. We do have some strange tool calls, so we're going to start to talk about that. So what I just did is I literally just output this into a common folder. So this would be the way I would see it physically in my machine. So if I came in, I edited it. Oh, that's the wrong one. Let me make sure I posted it to the right spot. Do this again real quick. Yep. Post test file. Let's overwrite it. All right, so it's output. We're going to open it up. And of course, I probably have to refresh my directory. And now we're going to give me a hard time. Sorry guys, give me 1 second here. I'm not sure why it's not showing it. I just got to double check my path again. I'm going to repick this. You always have this stuff all set and ready, you think, and then you make one little change, and everything goes bye-bye. Oh, there it is. Oh, it should still be there. Okay. Oh, let me reload this machine. It's like it's not updating in my directory on my end. So what I'm using here right now while I'm reloading it, this is a piece of software we call SINUMERIK. It's a control emulator. So basically it's going to emulate everything I can do on the control. Here I had built a simple little machine that I was going to use as my mock 3-axis machine. And I just created a shared folder. And that's why when I was looking at it, I was seeing that I was posting that folder. It was certainly going into that folder, but I wasn't physically seeing it once I went into the machine, so I may have to just refresh it. Sometimes when I'm logged in, strange things happen when you're in these webinars. Okay. So that is back up. And I just opened that file externally just to prove that I'm not absolutely going insane. And it certainly should be here. Okay, there's my webinars. Ah, there we go. Perfect Nougat, I like to call that. Okay, so I output the file. Now, one of the things I'm going to show you, and one of the first things we wanted to show you that's kind of unique in the Siemens control, is we have the ability of calling what's called named tools. So you hear you see right there in the tool call, the physical name I'm calling up in the tool isn't a number. It's this 3/4-inch flat end mill. Well, it's really nice that they're giving us a full list of the tool libraries, because when it's time for me to set up a part program to build the file, I don't want to have to go searching down through the program to find out what the names were associated with it. In the same token, I'm going to have to go over and I'm going to have to create these tools. So what's nice is as long as this name matches the physical tool call, it's as simple as just copying and pasting the name over into our tool table. So when I go to build up my first run, build up my tool library, it makes it really quick. I can just kind of come in, select the type of tool I'm using, and just copy and paste the physical name right into it. And that's how I would start to build up my tools. Now, certainly I didn't want to have to go through building all 8 or 9 tools I have associated with this, so I just wanted to show you the one. But having that full library there available to us will quickly allow you to start to build up and get the tools physically in the machine. Now, it is possible that we could have created an external file and then run a part program to pre-propagate that. That's certainly something you could explore down the road. But the big trick when I have tool names selected is that the name that gets listed here in the tool table has to exactly match the physical name in my part program. So here they're doing the exact same call. It's a matter of just copy and paste. Now, I could have copied it right from the physical tool call event. It's very possible. I wouldn't use the quotes, just the name. That's all you need. The output code needs the quotes. That's what tells us to look for this named tool. Now, additionally, we've added some different things that we're going to start to see here to support graphic and so whatnot. But what the end toolpath is going to look like for this job is going to be this. So here we come in, we start to see some simple profile milling, walking around an output. Then we're going to get to drill a couple holes, center drill, some peck drill, some chip breaking cycles, and then we tap a few holes. And we end up with a little helical interpolation. So the post is already set up to anticipate all these different types of operation and handle these types of operations. But there are areas that you're going to want to tweak, that we're going to want to change around a little bit. Maybe you like the tool call we were talking about. Maybe you're a shop that doesn't like to use name tools. You want to use number values. So what we're going to do is I'm going to show you all of these unique triggers that we've embedded into the physical post. All right. Bring up the PowerPoint. So when it comes to modifying the post, there's going to be 2 basic files you're going to modify. You have the control definition file. That allows us to do more global types of adjustments. Maybe I don't like the sequence numbers the way they're coming out. You can change that. Maybe I don't want to break up arcs, or I want to break up arcs every 90 degrees. Now, that kind of stuff you can change around the control def. But when it comes to really being able to modify the output, we're going to go into this post file, and in the post file, we're going to start to show you some of these triggers that were embedded, and we're going to be able to modify or adjust this output by going into that given file. So what we'll do is we'll take a look at a few different features and functions, and then we'll go in, we'll modify it and output it, and you can start to see the difference in the result. So first and foremost, you know, we had to really think about compatibility and controls. You know, I mentioned earlier that this post supports both 828 and 840. And, you know, there are some slight nuance changes between those two controls. So what we did, and that's why it was so important for both Siemens and Mastercam to partner together and not leave this up to maybe an independent reseller or even in times the OEM integrating the control, because who's going to know the Siemens control better than Siemens, and who's going to know Mastercam better than Mastercam? So it really worked out well for the two of us to come together. We could kind of steer Mastercam in knowing where there might be areas that we want to pay close attention to. This is one of them specifically we're going to talk about here in a sec. And they can then tell us how we can fit the CAM system around these scenarios. So to give you an example of, you know, just making sure we had commonality, one of the big differences between the 840 and the 828 was how we handle work coordinates. So both controls support G54 through G57. So what you see here in the Mastercam interface is if I manually drive the work offset and I give it a value of 0, I'm going to get an output of 54. If I go up through to a number of 3, it's going to give me all of those consecutive work coordinates up to G57. But this was where the difference of the two controls came into play. In an 828, we support G58 and 59. But in an 840, we jump to our extended work coordinates. So instead of having a 58 or a 59, we jump up to G505 and 506. Well, this is where the disconnect comes in within our own product. If I am going to, say, give a G58 to an 840, it's going to tell me an unrecognized command. If I'm going to give a G505 to an 828, it's going to do the same thing. So what we decided, to make it the simplest and easiest without having to support two separate posts over just a couple of work coordinate triggers, is that we would then jump over to 507 and then support from 507 right up through our extended 599. So it sounds like a very simple scenario, but if you don't anticipate this, now all of a sudden you can have a post in the field that's writing a G58 to an 840 and it's not going to work, or vice versa, writing a 505 to a 828. So additionally, we started to then say, okay, well, how do we handle like tool naming convention? You know, that's kind of tricky. We don't want to tell you that you have to adopt one convention or the other. So first, we wanted to see if we could support the tool naming convention. And that was pretty easy to get going. So what Mastercam was able to do for us was be able to link the output name to the tool name that gets used right in the interface for developing the tool. So if you built a tool and you name it, or once you bring it into your operation, you have a name there. Whatever name is there is the name that's going to get driven out to the output code. But what if I don't like the name tools? What if I'm just used to, because I've been doing it for the last 30 years, using tool numbers? Well, that's okay. We're not forcing you to have to adopt this. But what we did was we decided to put a trigger or a switch inside the post. So as we go into the post and take a look at it, you're going to see there's going to be a switch called tool as name. And it's as simple as changing this to a yes or a no. And that's going to completely change your output structure. So what we can do here, and let me just switch back over to Mastercam, is we can start to show you where you find the triggers and how you start to modify them. And then we can start to see the difference in result. So I'm just going to work on our contour, one operation. If I was to look at the contour, physically under the tool information, I see that there is my 3/4 flat end mill. So this is the name that's currently being driven when I hit output. So you saw it earlier when I output the whole program, it was outputting the T equals and this name. So if I want to drive off the tool field, which in this case happened to have 294, it can certainly be any number you want, I now have to go in and change the post. So if I first post out this operation, or any operation for that matter, It's going to open up my editor. I'm just going to let it overwrite the file that I had there. Oh, I have to watch this. I have the file already open on my end, so it's yelling at me that it can't rewrite the file because it's open by my other software. Okay, so let me just shoot this out again. Oops. Boom, boom. We'll overwrite that file, save us a couple key strikes. Okay, so the editor comes up. You see here we have our standard 3/4 inch output. So now what we want to do is we want to open up that PST file, that file that you copied. And you could open this up into any external editor, but as well, you can open it up right in Mastercam. So if you're going to use the Mastercam Code Expert editor, it actually puts you right to the correct path, so you don't have to hunt for it. But you do just have to change your file extension type and make sure you hit Post Files. From here, we're going to see somewhere in the list, you're going to see the Siemens 3-axis PSD. Now, you're not going to see the PSB because you're not going to be able to edit that anyway, and you don't need to. We're just going to pick the PST file, click Open, and it's going to open up as like a text editor here in the control, or in the code editor. Now, this first section is all commented out. That's what the pound signs are. But there's a lot of detail here. So if you want to start to learn what this post is capable of, all of these triggers are well documented of all the different features. Like for argument's sake, we were talking about the work offsets. Well, we see right here, G0, 54, G57 is number 3, number 4 goes to 507. So there are a lot of great comments here. So if I start to scroll down, start to talk about the tool naming, start to tell you, how we handle some of this functionality. And then if you move down just past all the comments, you get to the start of the post, first thing you're going to see are these switches. And the switches is what's going to start to change this functionality. So it's really as simple as coming down to where the system says yes, changing it to a no, saving the file, and close it all up. Now if I re-output this file, now you're going to see I get tool 294 as opposed to what we had earlier, which was my T equals 3/4. So there's my tool 94. So now we can quickly adapt this post to how the user wants to use the system, not as opposed to us telling them, well, you have to do name tools or you have to only do numbered tools. It's a matter of changing that trigger. Now, I want to say the default post, I think, comes out or when downloaded with name tools set. So it's just one of those things you want to be aware of. Now, from our standpoint, from the control standpoint, if I was to start running this file, right, here you see there's the updated one with 294. Well, 294 now has to exist. So if I go to simulate, it's going to tell me that tool is not there. So the 294, there you go, illegal tool number. The 294 is being driven by whatever is in these named fields. So if I wanted to create a new tool, I could do that. I could rename one of the tools, but let's say I'm just going to create a new tool. So now remember, it's T294. Well, you're only going to put the numerical value, 94, in the tool name. The T is automatically understood. So we'll just make this a 3/4 inch tool, however many flutes I want. Now if I come back, since 294 now exists, this tool is set up, we can start to simulate. I touch off some offsets, I could actually start to run this program. So we'll support either one. It's really up to you as a user how you want to adapt it. So there you go. So now we're starting to modify our post. I'm going to come out of here. We're going to switch back. And now we're going to look at how do we start to support the simulation. So you've seen the blob, the physical blank come up in our graphics. We were just looking at that. So how is that being driven? Well, what we did was we had to look at the way Mastercam has a bunch of different blank configurations, and we're certainly more limited to what they can do. So we really just kind of fit this around what we could support from the Siemens side. And in Siemens, we support either rectangles or we support cylinders, and specifically cylinders orientated in a Z orientation. So as long as you choose either one of these two options, The end result is going to be an output blank line, which is called a workpiece, and it's going to be pre-propagated. It's going to support any of the orientations. So, had I gone back to Mastercam and I looked at my stock setup, I can have my orientation point in any of the corners, in the middle. That's totally up to you. Bottom corner, it will propagate the right fields. I can pick cylinder. But had I picked another field, let's say for argument's sake, I picked solid, then it'll actually tell me that it can't build it because we don't support that configuration. So I can still use solids, I can still use files from the Mastercam side. The only difference is I'm not going to get a blank output. So if I look at the G code and I physically come in to this one, you just wouldn't get the workpiece blank. So from our perspective, you could see simulation as a wireframe. I could see the toolpath come around, but I'm just not going to get my visual with the physical solid model like you're starting to see here. Okay. So from there, we started to talk about tool comp. And tool comp can sometimes be a little challenging, especially when we're dealing with a control that has full 3D graphics and simulation. So we support all the tool comp variants, but the one that's always the stumbling block is comp where. So for those of us that maybe aren't familiar with the terminology of comp where is always going to output a G41 or 42, but the toolpath output is already going to be offset by the tool radius that you used in your CAM system. So what happens is when we get to simulation on our end, we are going to expect for you to give us the tool diameter or the tool radius in our tool table. This way I can show you what the size of the tool is. But in comp where, it's already been compensated, so they're expecting you to put a value of 0 in the tool table. Well, once there's a value of 0, there's no physical cutter diameter, and I don't get any simulation. So what will happen here, and you can see it in this little picture, you're going to go in, you're going to set up a 3/4 inch diameter, or the radius equivalent, depending on how your machine's set up, and you're going to run it, and you're going to get this huge output because you're going to get double compensation. So what we decided to do is we decided to leverage a little command called TOFFR. And what it does is it allows us to modify the radius on the fly. And the end result is going to be giving you true toolpath compensation. I still get a physical comp output, but I now can give the system the full diameter. So what we're going to do is we're going to show you kind of what that looks like a little bit. And let me jump back over to here. And then we're going to show you how to potentially disable it had you not wanted to use it. So some guys may be so used to always putting a value of 0 that they don't want to have this extra step, and that's certainly okay. So if you look at my program here, I have specifically selected where as opposed to one of my other comp strategies. So if I go through where, I output my toolpath, what you're going to see, because I have the trigger put up physically on, you're going to see a new command come in. Did it again. Let me get out of here. Yeah. Sorry, guys. I got to remember to stop editing the file before I try to rewrite it. Okay. So I output it. I post it. And what you'll see with the TOFFR function loaded, and that is not applicable anymore, you will see this statement come out, TOFFR. And what TOFFR does is it says, modify the active tool radius. So what we're doing is we're saying, okay, well, you told me I got a 3/4 inch tool in the tool table, but I already know this tool path has been compensated by 375 by half the tool. So we're just going to remove it. So it's kind of like fooling graphics. So simulation sees a full cutter diameter, but I don't get double the compensation. Now, in this case, we have it output a couple times. This is not additive or cumulative. So once it's there until you adjust it, and it would get canceled on the next tool change. So here, if you happen to output it and it's a little redundant, it's not going to keep building on itself. That's absolutely okay. But what it's doing is it's now keeping us from getting that double compensation by this simple statement. Now, if you want to get rid of it, or you don't like that functionality, You can go in and we can certainly modify that. So that's where the other trigger comes into place. So if I go back down to that same section that I had before, and we'll just run right down to it. One more step up. So we have TOFFR. Let me just bring it up on the screen a little bit more so you guys can all see it. So this is the same scenario, and if you read through it, it'll tell you yes or no. Now, we did put an extra message in here because if a guy's still not familiar with this functionality and it's at yes, you may want to warn him that this is going to happen because, you know, he's going to go and put a 0 for his tool comp and he's going to get the other effect too. So we want to be careful that people understand exactly what this function is doing. So set it to no. It won't output the TOFFR. Keep it at yes and set this to a yes, and you'll actually even now get a warning that the TOFFR is active. So if I close that down and output it one more time. So here's your warning statement, just making sure that you're aware that this function is being enabled. And if you want to, you can certainly change it. So now if you look at your output, we still have the TOFR, but you even get a warning in the output command. So usually I would say, you know, keep the warning there when you're first getting used to the function, or maybe you have a couple different programmers using this post. Once everybody knows what's going on, you don't want to keep seeing the alarm. Go in, change it to a no, and the alarm goes bye-bye. So that's what I'm going to do because I know what TOFFR does. All right, so we'll set that to a no, save it, and we'll keep moving along. Now, there are some areas where we ran into situations where Mastercam may allow you to do something that we don't directly support. So to give you an example of that, one of the things you can do in Mastercam, if it's allowed, is you can turn cutter comp on in an arc statement. So whether it's the TOFFR or the standard comp, it will let you turn that on right at an arc. So in this case, you see the lead in, I have a 0 length, but I have a radius of 50% of the tool. Well, in the Siemens control, it's one of the few things we don't allow you to do. And generally, you'll find with Siemens, we can allow you to do just about anything. But when it comes to comp turn on, we don't allow you to turn comp on during an arc event. So certainly we can't change the Mastercam HMI to keep you from ever doing this input. So what we've done is we've added error catching and error trapping at the post level to at least catch you, let you know that this condition occurred so you can go and make the change. So in this case, I'm going to see the physical error pop up the minute I tried to post the system or the program. Now it's just a matter of coming in and just giving it just the slightest line length. I mean, this could be a few thou. We just need to see some semblance of a straight move when we're turning comp on before we get into that arc, and then we're good to go. So not only will it warn you, but it won't output the arc, the comp either, because we know it's not going to work at the machine. So there are, a few little areas throughout. We're certainly not going to pick out every one in this webinar. We don't have the time for it. But there were just a couple areas that we anticipated this. Just to give you another example, we were talking earlier about the blank and how we only support rectangles or cylinders. Well, that's an area. If you pick the other one, we will give you an error or a warning telling you that's not supported by the control, and then you won't get that result on the output side. Okay. So from there, we have all of our drilling cycles, and we spent a lot of time making sure that the cycles are supported and supported properly. Now, it's worth noting that this post is written for standard Siemens language, Siemens protocol. We do have a mode that a builder can turn on if he wants to, called ISO compatible mode. And ISO mode is going to follow more of your standard ISO protocols, your G81, your G82. We did not comply with that. We complied with our standard Siemens protocols. And we went through a lot of pains to make that happen. But the reason being is there's a lot of advanced functionality in the Siemens control you get when you run an R mode that you don't get in ISO. The other problem is you don't always know that the Siemens controller had been commissioned for ISO mode. So from a post-CAD/CAM development standpoint, you could say that you're going to output ISO and drop it in a machine. It may not run. It really all depends on if the OEM decided to support that mode. So by utilizing our standard cycles and embedding them in, we get really the most capability you're going to be able to experience from this post. So we're supporting all of our standard drilling cycles, as you see here. Now, one thing you want to pay attention to, depending on the cycle you're in, what we had to do is we had to use the Apply Custom Drilling Parameters section to get more variables. If you know Siemens at all, you know we don't give you one way to do something, we give you 10. And we don't give you 3 triggers, we give you 30. We certainly, because it is advanced control, there's no shortage of functionality within our CAN cycles. Well, because of that, we did certainly run into scenarios where we just didn't have enough real estate to turn everything on. So what you want to make sure is when you first come in, when you're first starting that operation, that you select the Apply Custom Drilling Parameters. Now, if the cycle doesn't require it, that's okay. You want to leave it on anyway. But you'll see here, like with the PEC drilling, once I click the Apply Custom Drilling Cycles, you're going to get the fields will pop up, the extended fields. And that's important because there's going to be stuff down here you're going to want to make sure you pay attention to when describing the CAN cycle. Now, what's nice about working with the CAN cycles and what we did from Mastercam's HMI side is we tried to get everything to align. Now, one of the big benefits to using our cycles, and they read like this, like you see in the top. This is how you would see it in the physical control. MCall sets up modal drilling, and then it's going to stay cycle 83, and then a bunch of variables that are comma delimited. Now, it's never intended for an end user to edit anything in here. This is one of the things you get when you're running in Siemens mode that's an advanced functionality. You're actually getting conversational functionality embedded into G-code. So if I simply open up the cycle through our editor on the control, I get this input screen. And this is what we call a data mess. This is a conversational screen that allows me to write the drilling cycle. Well, what we did was we made sure that all of our names as closely matched to our descriptions. And we even went through and added in, if I have a variable, here you go, D, for my first PEC increment. But we put in the D here. So as people have familiarity with the control, or just moving from the control to Mastercam, there's going to be a commonality here that really kind of emphasizes and streamlines learning the cycles. It makes it a lot easier instead of having to understand, well, it's called something in Mastercam, but it really is going to do something totally different in the Siemens control. We really went through all the cycles and tried to align them as much as we could. So this is what you would physically see in the control. We'd see the output cycle, we'd open it up, and we can now go through and we can make any changes we want conversationally, and we'll see that all the variables are matching within the two systems. Okay, so before we get into this, why don't we take a quick look at some of the cycles we are supporting. So I'm just going to output a few toolpaths. So we'll come right down and we'll do some drilling, some PEC and chip breaker, and some rigid tapping. So I'm just going to create a part program. Let me make sure that I didn't leave it open. I didn't. Good. I'm just going to let it overwrite the one we had. So what you're going to see as we start to output the toolpath, let's open up the file. Here's our different operations. So we're going to do some spot drilling, drilling 2 different size holes, and then we're tapping 2 different size holes. In this case, I was tapping an inch thread and a metric thread on the same part. So this is what I was just talking about. You got your MCall cycle. So as long as the post is complying with our protocol, you can open up the cycle right at the control, and here I can conversationally make any editing changes I want. I know exactly what variable I need to switch back in Mastercam because the variable names are all matching. So you can quickly and easily support the system. Now in this case, this is a simple center drill. So this is just our basic drilling routine, what we call cycle 82. Further down, we get into some PEC drilling. So there is our cycle 83, and this goes into the PEC drilling. So you can see how there's all kinds of different variables we support when we get into the drilling routines. Additionally, the same G83 cycle is used for chip breaker. So that's triggered right here with this field, chip removal with chip breaker. So that's part of the things we're able to do and adapt in supporting these cycles. We can change that, and it's writing to the same cycle, but changing some of the variables. So you see different variables pop up. We had to anticipate all that when we developed these cycles. Additionally, we're supporting soft tapping and rigid tapping. In the example I have here, this is just rigid tapping, but certainly it does also support the soft tapping variant of it. So here we can go in. Now this one happened to be set up as an inch thread. So here we were doing an inch pitch, and then later we were doing a metric one with a 6mm drill. So here we come in and we see, now in this case we're outputting the conversion. I think I have them backwards. Looks like I have left the naming at my tool numbers. So that's how we started to support the cycles. The cycles are embedded in that post file. They could be modified down the road if you maybe need to support some newer triggers. Certainly in Siemens, we're always adding functionality to our cycles. There actually was a bunch of new stuff that was just released for 4.7. So we'll be able to adapt the post quickly and start to support some of these upper functions as well as we move forward. Okay, now the next area I wanted to talk about was getting into a little more advanced toolpath with 3D specifically. So here we got a very simple part, just throwing some 3D surfacing at the part. And specifically, we're going to show you some of the things that we did and we anticipated when using some of an advanced high-speed cycles that are built into the Siemens control. So first things first, what we did was we decided we wanted to support our Cycle 832, which is our high-speed machining. But we wanted to see if we can make this as simple and easy for the user, the operator, to start to apply. And the first thing we looked at is, well, you in Mastercam know what you're picking, right? You know you're picking a roughing strategy or a finishing strategy. So why should we then force the user to have to tell us that Cycle 832 is going to be in a roughing or a finishing strategy? Why don't we make this as automatic as we can? So that's exactly what we did. So the first setup is going to apply automatic mode. Now, I'm going to show you how to go in and trigger this and turn this on. But really, once I go into the cycle, I'm going to go to the miscellaneous values section in Mastercam. I have an option field here. 0 is automatic, 1 is manual. And it's as simple as changing this from automatic to manual. So as long as this is at a 0, I don't have to fill out anything else. The system will automatically figure out what operation I'm in and then output the appropriate toolpath. Sorry about that, guys. Output the appropriate toolpath, or shall I say, Cycle 832 setting to match that toolpath. So what I would see here is I'm allowing it to be auto. I'm in roughing. So my strategy output is actually a roughing strategy. We set it to what we decide the appropriate tolerance should be for that strategy. And there's where I would see the output. Now there are some additional modes. This is being triggered by this Cycle 832_Prismatic trigger. So back in the post, as long as this is at a no, and it says right there in the comment of the post, as long as it's at a no, it's going to output the Cycle 832 line. Now, additionally, if we look at it, we also wanted to give you the ability of maybe overriding these values, because you may want to choose a semi-finishing strategy. You know, we support 3 different strategies of toolpath when I do high-speed: roughing, semi-finishing, and finishing. Well, if you look at Mastercam, Mastercam supports either roughing or finishing, and then you would obviously have adapted your step-overs and your strategies to more parallel of semi-finishing, but they don't have an option as far as the cycle is concerned. So this is an area where we wanted to be able to manually override the output. So again, in the miscellaneous values, simply putting a value of 1 allows me to then pass through some different options. So here I can set what my machining strategy is: 1 for finish, 2 for semi-finish, 3 for roughing, and then what my chordal tolerance is going to be. And that'll directly output into Cycle 832, and I can see that right at the control. So if we look here, and we jump over to Mastercam, and let me just make sure I'm going to get out of the program. I'm going to now move over to this high-speed program. So let's open up that one. Sure, we can save this. And this is my little high-speed sample, nothing all that fancy, just to give us a couple operations to play around with. So when I edit one of the cycles, for argument's sake, and I go down to miscellaneous values, I'm going to look to see what this is set to. Now, the first time you come in, it may be checked off. So you want to uncheck this so you can manually override these miscellaneous values instead of letting them just default to the post variable. And I can come in and I can make some changes. So as long as I have this as an auto, it is going to be looking back at whatever type of toolpath I have selected here. So here I have a roughing toolpath. My miscellaneous value is at auto set. So if I output, I post this cycle out, and we're going to just let it overwrite that one. That's fine. You're going to start to see, let me open up, our cycle 832. And this might not mean a lot to you without opening up the data mask, but basically this is where we're passing through our chordal tolerance. We then have a numerical value that matches the roughing, and that's why if you saw in the description, we said, 3 is rough, 2 is semi-finished. That's for the variable gets passed on our side. And then the third place is really more of a version control segment. So normally this would just stay to a value of 1. This does change when you get to 5-axis toolpath, but right now we're only talking about 3. So physically at the control, if we were to look at the output toolpath, here I can come in and I see it's picked this strategy. Now, the end user can certainly override it. That's the beauty of being able to output to these cycles. So I could maybe change my tolerance here, and it'll rebuild the cycle. Now, speaking of version control, you see how this now goes to _rough. So we, on our side, have changed a little bit cycle 832. But we used to use just a number value, now we use a named variable. But depending on the version of software you're running, that could give you a compatibility issue. So this is another area where we thought about all the versions that are out since operates come into effect, and how do we comply with something that will work with everything. That's why we're using the numerical value in the post. Okay, so if I start to look at it a little bit more, we can certainly bounce between those two different triggers just inside of our parameters field. But one of the things that we started to think about is, well, what if somebody doesn't want to use cycle 832, but we want to get some advantages of high-speed functionality? And that actually can happen more than you might realize. For one, cycle 832 is an option. So you may just not have the option in your control. It depends on the control that you have. Maybe you have it, maybe you don't. Number two, what if we're dealing with legacy controls? So cycle 832 has been out for a little while, but you could potentially be outputting to an older machine, and maybe it's not fully supporting it, or it's not supporting all the triggers of the latest version of cycle 832. And then, we get some cases with maybe some lower level or some entry level machines where they're just not really set up properly to run cycle 832. So what we did was we created this prismatic mode, this prismatic machining mode. And what it does is it lets you now start to trigger the unique functions that build up cycle 832 without being dependent on cycle 832. And that's where we have that switch, that trigger that says cycle 832 prismatic, yes. So remember I said earlier, you set it to a no, it's going to use 832. Well, this is why it's named what it's named, to support this function. So what will happen here is by coming in to my post processor, I can close that, and let's close that. All right. I want to just change my names back to yes because I like that better. Okay. So you see where we have prismatic mode at a no. If I simply change this to yes, now our toolpath is going to now start to output these different settings. Now the triggers that you just saw, so if you look back here, we have the ability of changing the 0, the 1, the 2, the 3. There are unique strategies that we've preset that we feel are a good starting point if you are going to want to try to use this mode and not use cycle 832. But this is going to require, if you want to run the machine in this mode, more customization. One thing, for argument's sake, that I would absolutely make sure I do is make sure that the machine OEM is okay with the commands we're using. You know, one of the commands you might see here is a command called brisk. Well, some of your higher-end machines that have been highly optimized as far as from a servo tuning standpoint, you turn brisk on and you would swear that machine's going to walk across the floor. It's responding that quickly. So you'll find some builders don't ever want you to run brisk. You need to know that kind of stuff when you're working with this. Also, you know, I wouldn't suggest, if you need to get to this level of customization, doing it as maybe an end user using this post. This would probably be something that's better left up to the reseller who can be supporting you with this post. But it's all right here, all available for our customization. So if we go back and I now output it, I can still use the manual or automatic. So let's say I chose a manual strategy. I chose a manual strategy. I'm going to use a semi-finishing routine, and maybe, now the tolerance itself is hard-coded when you get to Prismatic. So this tolerance field isn't going to do anything. That is only applied in cycle 832. So it doesn't matter what I leave this at. So now if we output it, physically post out this post, and we'll just overwrite it. That should be good. Save us a couple of clicks. Bring it up. Okay, so here, let me zoom in so you guys can really start to see it. Hopefully it makes it a little bit better for you. Here is what's replacing that cycle 832 call. So we got a couple different corner rounding strategies, end of function, we're turning on a buffer control, we're turning on our compressor. And this is where it's important to know what all these discrete functions do. Because if you don't have cycle 832, you also don't have this compressor potentially. So that's part of the advanced surface option. So this potentially will need to be modified depending on how you're applying it. Now, where does it get modified? Well, it is right here in the post. So if we go back to our post, I'm going to zoom up a little bit. If you want to find the segment that's controlling it, what's really quick and easy is if you just highlight Prismatic, or any of these functions if you want to start to dig a little deeper. Now we just do a Control F. It's going to bring us down to the section in the post where all this stuff is hard-coded. So we have 4 different strategies really: a deselection mode, that's turning it off once it was turned on, and then our finishing strategy, our semi-finishing, or our roughing strategy. And we're hard-coding all these variables here. So once you decide what is most appropriate for your machine tool or the machine tool you happen to be working on, come into this section, make the changes here that will better match the machine. But this is going to take a lot more customization and a lot more knowledge of the machine. And don't get the assumption that you're going to get the machine and make it run better by tailoring this. You're never going to run better than cycle 832. This is really, we only put all this trigger in to support older systems or to support poorly commissioned machines. But at the end of the day, cycle 830 is there. It's there for a reason. We put it in because guys could never get all these functions set up right. So now it allows the builder and Siemens, us, to really get your machine set up for the best possible condition to give you the best possible performance. So again, I am strongly recommending, if you have cycle 832, that is the mode you want to run. However, if you don't, or there's a problem that you think with cycle 832, this function was embedded here for that specific reason, so we could start to anticipate that kind of stuff. Okay. So here we started to see a little bit about what I just showed you. This is just showing you our 4 different technology areas and what that segment of the post would start to look like. And then you can play around with the triggers to change that kind of stuff. Well, we went through a lot of different material. Hopefully you guys certainly found it educational. Yeah, obviously my hope here is those of us that are starting to utilize this post will be able to really take advantage of some of the key functions and features. I do want to open up to questions now. I see some questions look like they came through, so I'm going to start reading through them. And now as you guys come up with some, please enter them in. You can either put them in through the Q&A or the chat window, whichever you have up. Looks like one of the first questions I have, what is the advantage of name versus number for tool name or tool as a name? That's actually a very important question. So you're not going to lose any functionality if you do one or the other. But the reason why we created the naming logic in the first place is for tool life management. And it's really for the ability of associating two tools together. So what you have here, if you look at our offset table, is we have a column with an ST. That represents sister tools. So let's say, for argument's sake, I take this 3/4 inch end mill, and I'm going to assign a life to it. And the life's done under wear, and I can say, hey, what's my time in cut, or how many pieces do I want allowed to cut? Whatever my time management is, it is what it is. But what happens when the tool expires, when it's dead and it's bad? So as long as you have the option of sister tools, what the system will do is it's going to look, and let me just create one for you real quick. It's going to look for a tool in the library that has the exact same name as the other tool. And when I build the tools, as long as I use the same name, it's going to give me an associated number, a sister tool. So that's why we use this name and why we're not linked to like pocket locations or physical number. Now, I can do the same thing with the physical numbers. So I can have 294, and now that 294 is associated with this 294. But from an end user perspective, it's a lot more confusing to a guy to think, why do I have two 294s in there? It makes more sense to say, okay, I got two 3/4 inch end mills in there. That makes sense. So it's really just to keep it a little easier on the operator's perspective. It'll work either way. But certainly, from the operator standpoint, it does make it a little simpler. The other reason why we like to use name tools is you have a comment here, right? So at any point in time, I don't have to remember. I don't have to be looking at the diameter of the tool. I'm digging in a program. I don't have to look for a comment section. I see the tool. I know what the tool is. I'm not trying to figure out what was tool 94 again. So that's another reason. Okay. Let me start going through some of these. We've got a whole bunch. It's great. I appreciate all the questions. What version of SINUTrain are you using? So it looks like somebody noticed the new version. This is our latest version of SINUTrain for version 4.7. We released it a few months ago. So it does look a little different than the previous version. And if we start to dig into some cycles, you would start to see there's some new options in there too. Very similar to what you guys might be used to in the previous version, but we kind of gave it a little bit of a facelift. And additionally, we've added some functionality. So that's what you're looking at. It's version 4.7 SINUTrain. And this would be kind of the way it would look on the machine. So Jeff asked, how do we get access to this post? So earlier I had mentioned, and I'll jump back to the slide in it, as long as you have and let me just cruise on up here, as long as you have a login into Mastercam, go to mastercam.com, log in with your user login, and go down to the Tech Exchange section. From there, when you go to Tech Exchange, you will see a list of all the available posts. You just highlight posts. You can do a search for your version. I think when you first come in, it always defaults to 2017. But if you need X9, you can pick X9, do a hit search, and it'll show up. Right now, I think there's just us and one other post currently in here. And we got in there first, mind you. Anyway, but yes, you will find it right there. Now, if you don't have a login to Mastercam and you have a valid SIM number, I believe you can just go in and create the login. Don't quote me on that. You may want to talk to your Mastercam rep to verify that. But I'm pretty sure if you just go through, register with them, I think you link it, because I think that's how I did it originally. You link it to your SIM number, and then you can have access. If that's too confusing, I would certainly say the other option would be to request it through your reseller, and you should be able to get it right from your reseller as well. Would Mastercam and Siemens develop more posts for other controls. Great question, and yes. So what we're doing is this was the first kind of lead in to this partnership, for lack of a better term, or mutual venture, shall I say. So we wanted to start with, let's face it, probably one of the most common posts, and especially a building block for other more advanced posts. So the thinking was, if we get the 3-axis post out there and a reseller has to then build a 4 or 5-axis post, he can take this and use it as a building block and start to create it. And then from there we can start to expand it over time. So it looks like the next post we are going to do is going to be a basic lathe post. We are getting some pretty big requests for a turning post before we get to more advanced milling. So we'll build a 2-axis lathe post. I'm sure it'll most likely have live tooling support in it, but probably not Y-axis or subspindle or anything like that. Just a basic lathe post. And then we'd like to get into a 4-axis mill post, and then hopefully eventually a 5. The 5-axis is always going to be tricky, because when you get to 5-axis, there's always a lot of customization specific to the machine tool. And you got to remember, from our perspective in partnering the way we are at the corporate level, we need these posts to be as universal as possible. So any reseller for Mastercam or end user could take this and adapt it to their specific machine. If we write it in such a way that it's just tethered to a very specific machine makeup, machine kinematic structure, right? So it's a 5-axis post, but it only supports a B, C table, well, then it's only going to be worth it for a small segment of the market. So when we get to 5-axis, we're going to have to think it really through to see how do we make it a universal post that people can use to build on. But yes, we are trying to go that way. Why can we use toolpath tolerances to trigger the rough, semi-finish, or finish? Why can't we? I guess we could have used the toolpath tolerance. That's a good question. There are cases where you could say that the tolerance specifically, there may be overlaps. So I may use a tolerance in finishing that you would think would be for a semi-finishing operation, but when you go to finishing, or you're going to go semi-finishing or roughing, there are other commands as well, kind of like you saw in the prismatic mode, that are being turned on. So I may want to take advantage of the specific commands that were established for finishing, but have a little wider tolerance band. And this way we didn't have that potential. And I'll be honest with you, I think the other thing would be, we didn't really think about just tethering the trigger based on the tolerance. But I know personally from running the toolpaths on many machines that there are plenty of cases where I would run a broader tolerance in a finishing op, let's say, that maybe I would normally use for semi-fin, but I know there's commands in the dyne-fin statement that's getting triggered in the back end that I want to be active. So that would probably be the bigger reason. Is Sinutrain free for Mastercam resellers? No, unfortunately, Sinutrain's not free, but we do have a new version with 4.5 where if you're using the demo machines, you can use it without a necessary license. So Sinutrain itself has a pretty broad range of capabilities. If I look at Sinutrain here real quick, I'm just going to shut down this one machine. It is as advanced to the point where I can actually pull out physical backups out of customers' machines, and I can build a virtual machine in Sinutrain. So we create what's called a digital twin. So like here I see a DMG Mori DMU50. That DMG Mori, I built this from an archive out of a machine. If I go in and run this, it's cloning the guy's machine. So there's some pretty advanced functionality you get within Sinutrain. And if it's something that you feel that there's a value for you guys to have, you can purchase Sinutrain. That's not an overly expensive piece of software. Should be under $3,000. But with that being said, if you want to play around with Sinutrain, what we do allow you to use is we have these template machines. And when you go to create a template machine, as long as you build the demo lathe or the demo mill, so that would be a standard 2-axis lathe with live tooling, or a 3-axis mill, you do not need any license required. So my suggestion for you, if you think that this is a tool that would be handy for you, download it, install it, run either of these two machines. So you just build the demo lathe or the demo mill, And then moving forward, if you want to get into more advanced machines, 5-axis machines and stuff, you could always add the license later. You don't have to uninstall the software. It's the same software. You end up adding a license into it. Now, as far as getting SINUTrained, if you go to that CNC4U website I mentioned earlier, that was in the top, you can put a request in and we can send you out a CD. There are also links I could send you if you want to email me for a download. The only problem is it's big. It's a couple gig. So we tend to find that the mechanism for download isn't always the greatest. While using tool names for tool load, it's required. Requires quotes, but if we... Oh, I think the question really is between tool names and tool numbers, the quote scenario. So if it's a tool number, the quotes aren't required. So T1, T2, T3. You can build it with quotes. So if you want a commonality on your side, so you could say T equals quote 1, end quote, or T equals quote 30, end quote, but it's not required. When it comes to the name of the tool, however, my half-inch end mill or whatever, that has to be within quotes. So usually most of the time I have guys, if they're using numbers, just do T and then whatever the number is. If they're using true names, embedded in the quotes. I believe that was your question. When do you think the 4th and 5th axis post will be available? Weeks, months, years. Weeks or months? Probably not. Hopefully, I would expect within 2017 we'll probably get to the 4-axis mill. Once we get the lathe done, which will happen pretty quick, the 4-axis mill is going to happen real fast because it's really already 90% done. It's going to be this post, just adding 4-axis functionality. The 5th axis, I would be shocked if we get onto that before 2018, to be honest with you. All right. There was one question, why not D? I'm not sure I follow. So Jeff, if you want to elaborate on that, I can certainly talk more about it. Just enter that in. Okay, there was another question on the 5-axis post. Oh, you said don't worry about it. All right, and let me see what else. Oh, this was one we didn't talk about. So what if I don't want to use the physical drilling cycles from an output standpoint? So that can all be changed inside of Mastercam. Just because we built the cycles doesn't mean that you have to take advantage of them. Some guys don't want to see the cycle output; they want to just see, G1s and G0s. So that's one of the things where you would go into that control definition file. So if you go and you edit your control def, and inside the control def file, there is a spot under machine cycles and mill drilling cycles. So in here, right now we have it checked for the system to utilize all of these CAN cycles. If you uncheck these and just save this file and come on out, if I repost the drilling cycles, it will not post with any of the CAN cycles. So you won't get the cycle 82 or the cycle 83. It'll literally just put out discrete rapids and feeds. This is a good one too. So somebody must have noticed, and when I was maybe outputting the surface, that it looks like a lot of decimal places. And yes, that was done intentionally. So if we look at, and see if I have it still open. Yes, I do. If we look at the program, we see I'm supporting up to 6 decimal places here. So this is one of the things that, in working together, we were able to educate Mastercam on our control that will dramatically give higher performance and quality in the Siemens control. And it's kind of counterintuitive to a lot of other controls. We're usually used to the more data we give it, the slower everything goes. Well, for us, number of decimal places can significantly help alleviate rounding error issues. So believe it or not, I've walked into numerous scenarios, service case scenarios, where a guy was complaining about surface quality, cycle time, and just strictly increasing the number of places, I was able to reduce his cycle time because there was less rounding error and increase his surface quality. So we were able to maintain higher rates of velocity because things were physically connecting better, and the surface quality came out better. So our standard rule of thumb in any post, and I don't care how simple the machine is, 6 places for an inch program, 5 places for a metric program. And that's what we have Mastercam automatically doing here. You can go out to 8 places. I mean, the more places you give me, the better off you're going to be. It's not going to affect us. It's only going to affect us for the better. Other areas that we did little triggers in, you'll notice if you start using this post, when cycle 832 comes into play, you won't see any arcs output. So cycle 832 is running a compressor in the back end, and the compressor is our spline interpreter. So what we're doing is we're taking the data points and we're actually creating a spline. And what we run in the Siemens control isn't the data points, it's the spline. Well, if you throw arcs, it screws up the calculation for creating the spline. So we automatically linearize your output once 832 is on. So no matter how a guy may have modified the control DAP and he's forcing arcs all the time, once 832 comes on, you're always going to have a linearized output because we know that's going to give you the better performance. So those are the little things that we've embedded in here, and there's lots more just to try to give you the best possible performance possible. How do we know what options are available in the control? I mean, it's usually going to be a question for the customer. They may or may not know. A lot of times that's an OEM specific question. What you've seen here, everything we talked about outside of cycle 832 was a standard feature. Really, it's just the cycle 832 side you would need to know. And really, that's also just educating yourself about the Siemens control a little bit. There's interfaces you can go to within our control, a license manager, where you can go down and see if advanced surface is there. So if you're finding that you're not getting the support maybe from the OEM, the machine tool builder, especially some of these import machines, it may be a little bit challenging depending where the machine came from. You can always reach out to us, and if you're trying to figure out if an option's there or not, let me know, and I can steer you how you can get that information out of the control. Oh, somebody was asking about a latest version of 4.7. So the newer version of 4.7 is out on the standard download website. So send me an email so I don't forget, and I can send you a link. All right, and then we have, is there a post switch for 828 and 840? So no, there is not. And that's what we were talking about a little bit earlier. We intentionally made sure that however we methodized everything, it would work in either or control. So this post will universally work in an 840 or an 828. Okay, so I think I got everybody's questions. There were a lot, and I really appreciate that. That's some great feedback. If I missed any, by all means, shoot me an email, give me a call. You guys had my contact information, and I'll be happy to talk to you about it in more detail. But with that being said, let me thank everybody for attending and helping me have a great webinar as always, and I look forward to seeing you guys in the future. I'm just going to stop the recording now real quick. Hold on.